So this is one environment, that is Jupyter Notebook we'll be working on. Now, if you don't have it installed and you want to work readily, then another option we have, and that option we have is Google Collaboratory. Okay, so if this option is not there readily with you, then you can just open a new tab and you can just type collab.research.google.com this way. So you can just look at it and you can type along with me collab.research.google.com and you can come to this particular page. So everybody can do this. Okay, so let's have a little bit of practice and so that we can move ahead. So this does not require any installation. This is a free tool. You just need to be logged in with the help of your Gmail ID. So just ensure that you have done login with your Gmail, and then we are making use of it. Yeah. So everyone can open up this particular page. I think another 30 seconds I can give. And those who have opened, they can click on this new notebook here. Okay, those who have opened, they can click on this new notebook and others can open up this particular page. Okay, so I believe everybody has opened this. Now you can click on this new notebook. By any chance, if somebody was not able to get that pop-up, and if you are at this particular page, you can go to File, and under File, we have a new notebook page. So you can click on this particular new notebook page. Yeah, so this is how a new notebook will get created. So I hope everybody is able to open a new notebook like this.
Yes, sir.
Okay. Now, once this notebook is opened, now few basic things which we should learn is how to install a particular library. That is something we should learn. So the good thing is that we can install the library from here itself. So for example, if I want to install a library called as NumPy, so what I can do is I can just write pip install NumPy and execute. So if I write pip install NumPy, in this particular case, what will happen? It is going to install this NumPy library for me. And let's say this pip doesn't work. Yeah, so you can see that sometimes it doesn't work this way. So you just need to add one exclamation at the beginning and then you just need to execute this particular command. So this is how it is going to help you with installation. Now, this particular library, NumPy, is already there in my particular environment and therefore I need not to install it. Okay, it is already installed. And the messages in the output, you see that it says requirement already satisfied. So NumPy is already there in my environment. I need not to install it. So you all can try this. So whenever you have something to install, this is the simplest way you can do the installation. That is pip install and the correct name of the package. Many times we don't put the correct package name and then it says the module not found. Okay, it is not able to find the particular module to get installed. So that should also be avoided. And next thing should be, once you are done with this, then you should know that how to import a library. So importing a library happens with the help of import nump by numpy as np. This is how we import a library. So everybody can start typing along with me and just get an experience that how you should actually start writing your piece of code. So now let me start with NumPy itself. In Python, NumPy, Pandas, Matplotlib, these are the fundamental libraries which help us first to work with datasets, especially with the data which is in the form of numbers, numerical data, and therefore the name is NumPy, numbers in Python. Pandas is another wonderful package on top of NumPy. and it gives us so many functions and better representation of the data in the form of a table. That is what a pandas package will be helping us to do. So let us start with NumPy first. So I hope all of you have done these two steps. And now NumPy help us to create some arrays. So if you are from some other background like uh, we have options like MATLAB, R programming. So if you have done anything like that, then also it will become quite easy and simple for you to work with this. Okay, so let's begin as I said. So now, first of all, we will create a simple array. Okay, an array is collection of elements, and NumPy is best for helping us with arrays. So first of all, you can write ARR or whatever name you want to give. So I'm just writing ARR, which is representing array. And I have imported NumPy as NP, so I'll be using NP dot. So import NumPy as NP actually means that NumPy is the library name and as NP, okay. So NP dot, so here I'll have to write array, NP dot array. So after writing NP dot array, what I'll be getting here is, I'll be getting here, I'll be passing here a list. So let me create a list, or let me make it simple for you. So first of all, you can create a list over here. Okay. So li is equal to, this is a list, and we can put some numbers into it. Let's say 1 comma 2 comma 3 comma 4. So numbers into it, and here you can pass that list, and then you can just try experiencing print ARR. Along with that, you can also print that what is the type of that. So here you can see that I have a NumPy array created over here, and li is equal to 1234 is a list. I'm passing that list into np.array, and it is helping me with a list. Okay, so that is how NumPy actually works. It creates lists. We used one function, that is array, and array function was used to create the list. Similar way, we have multiple other functions which will help us to, so other functions we'll try to get and try to see the shape of the arrays like 2D arrays or 3D arrays. So here we have ARR, and I'll just print certain things. So print, or I can print it here only. So you can type this much. So ndim is dimensions, then shape is the shape of the array. Okay, with subsequent examples, it will be very clear. We'll be able to understand easily what these things are. Okay, so this one is 1D, one dimensional array. Okay, just one, here you can see that I have sent one list having 1, 2, 3, 4. Very similar way I'll be, okay. So you can basically make use of, you may type it or just take the same piece of code and make some changes. In the list, I'll make some changes now. So I'm removing all the data. It's an empty list as of now. Now let me add some data to it. I've added a bracket, 1 comma 2. Now you can see the change. You can see that the ndim becomes 2, dimension becomes 2, and the shape becomes 2 by 2. So just try to understand why this is happening, and I'll explain also. So now if you understand here that in this particular case I have a list, and inside the list I have 1, 2, 3, 4. In second case I have a list, inside a list I have another two lists, 1, 2 and 4, 5. So what is happening here? The output comes like this: 2 by 2, 2 rows, 2 columns, Okay, 2 rows, 2 columns. And here the output come like this, right? So therefore that changes. The way you will pass the data will change the shape. So if I ask you that I need data as 3 by 2, okay, 3 by 2, 3 here, 2 here. So make it 3 by 2. That kind you try. 30 seconds you have. Just try that. Then I'll show you. So let me also show you this. So it is all about how we are passing the input. So I'll be passing the input in that way that it becomes 3 by 2. So it is all about rows and columns. The first thing is taken as rows and the second thing is taken as column. So I'll be taking one row, then second row, then third row. So 3 rows I have taken. Okay. And now it depends like how many elements do you want inside the that particular row. It depends. So how many elements do you want to take? So earlier I was taking two elements. So here also I'll be taking two elements only. So let me take 1 comma 2 over here, and then here also I'll take 6 comma 7, and then here also I'll take, let's say, 8 comma 9. This way I've taken, and I'll execute this. So you can see that we have 3 rows and 2 columns. So we need to check the shape of the list, what input I'm basically sending. Depending upon that, I will be getting the array. Okay. Now, second part to work with is that once we are able to create the arrays, we should be able to work with indexing, slicing, stepping. This is something we should be able to. So indexing, slicing, now I'll tell you. So now we have ARR, now brackets, and 0. So it will bring 0th row. So here you can see. Okay, so this is called as indexing. So you want ARR of 1. Okay, so this is one thing which is called as indexing. So 3 concepts are there. One is indexing, second is slicing, and stepping. That this is the concept of indexing, slicing, and stepping. Now, how does it happen? It basically, indexing I told you, slicing basically starts with like this. We need to mention start point and end point. And in case of stepping, we need to mention start point, end point, and then step. This is how it happens. Let me show you how. So um, let me create one array. So a1 is equal to np dot array. And here I can pass list 1, 2, 3, 4, 5. This is an array. Okay, so here we can see we have this array. Okay, now what I will do is I will print a1. Okay, if I print 0, this is indexing. Then if I do print a1 and here 0 colon 5, this is slicing. And then if I do print a1 and I start with 0 1, I start with 1 and till the end, step size 2, all the even numbers will come. So just try to understand what is indexing, what is so this one is indexing, this one is slicing, a part of the array, and this one, if you see, so are these making sense how this is happening? So if I want all the odd numbers, so bring all the odd numbers. How will you bring the odd numbers? Just by changing, this will bring all the odd numbers, so you can see. Great. So you all can keep on typing along with me. This is fundamentals basics. You should have understanding of NumPy, Pandas, Matplotlib. Okay, so let's move ahead. So this is indexing, slicing, and stepping, basic part, which then if you want to make some addition, you can basically use again your indexing. You can make addition of two elements within the array. For example, I want addition of a1 of zeroth element and a1 of third element. You can do that. So here you can see we have 5. Okay, now let me get into 2D arrays. Okay, so if we have a2 is equal to np dot array array, and then I have like this. This is one dimension, and now if you see that in this particular thing, I would like to get. So now I'll do print, and I do a2, and here if I do 0, it will bring me 0th row. If I do print a2 and then 0 colon 2, it is going to bring me the 2 rows. Okay, because only 2 rows are there. So here we had created this array, and in this particular array this is 2-dimensional, and the shape, if I want to show you, so this is the shape of the array. Shape of the array is 3 by 4. 3 rows are there and 4 columns are there. In this case, if you want to do slicing, you can do slicing with row wise and column wise. Both ways you can do. So row wise slicing also we are able to see. Okay, this is row wise, and only column wise if you want to do that also we can do. It will be like this, only column wise. So here I'll write this way, and I just need from 0 to 1, so I'll write 0 to 2. So only first two columns it will bring. Okay, so if I write this way, it is going to bring only first column. So here you can see that it is just bringing first two columns. Okay, and rows it is bringing all. So if you're writing it like this, if you're just writing it colon, in that case what is happening when you're just writing colon, it is starting from the beginning and it is going till the end. Okay, starting from the beginning going till the end, that is how it is doing. Okay, so this is what is slicing in case of 2D array. Now let us move ahead, and if I want to understand about the data types, then we have integer, boolean, then we have unsigned integer, float, complex, then we have time, date time, object. So multiple variables are there. If you want to check the data type of a particular array, we can do ARR. This is a2 dot d type. So a2 dot d type should give you the data type of that particular array. So here you can see that we have got the data type. If you want, you can create an array of characters also. So how can you do that? Um, let's say we have names is equal to then np dot array array, and here I'll be passing a double ple apple, then mango mango, then okay, this is how I'll be writing. Then uh, graps grapes. Okay, and now if I try to see print names names and print names dot dtype d type. Now you can check. Okay, so U6 is basically representation of object or string type. So that is how basically we can get to know that what is the data type of the particular array. We can mention also, like while creating, we can mention what should be the data type of that particular array. Even that we can do. So we can mention also, even that is a possibility. So let me show you that. Go to np dot array, and here let's say I have 1 comma 2 comma 3, and then here I can just put a comma and d type is equal to, and I can mention here integer, and here print a3 and print type. Yeah, but you cannot do one thing. Let's say if you are trying to do something like this, a4 is equal to, if you're trying to do np dot array array, and then you are putting over here, let's say a mix, you're putting a string value, or let's say you're putting a value as Pune, and then you are putting a value as 1 comma 2, and then you want to give the data type as integer. So that's not right. Correct. So because it's not integer, so Pune is not integer, it's a string value. So a4, and here print a4 dot dtyp type. You can see, okay, invalid literal for int with base 10 Pune. So this is how you cannot do. Correct. Yeah, so this was a few things about the NumPy, and there are so many functions also which create ready-made arrays. Okay, so there are many functions which create ready-made arrays with the help of NumPy. Let me tell you, if you want to create some more arrays, so a6 is equal to, you can do np dot zero, okay, zeros. So if you write np dot zeros, and inside it, if you want, if you will pass the shape, okay, so I'm passing 4 by 5, so it is going to generate a data of 4 by 5. Okay, that is also one option we can use to create arrays if you want some default and specific value. So this is one way of doing it. Another way of doing it is a7 is equal to, I want np dot ones, so I want all the ones to be there. Okay, so in that case, again, I can pass 3 by 2, so I'll be getting 3 by 2 ka. So this is a7. So you can see 3 by 2, okay, all the ones. So we have functions also which help us to create just by passing the size, they are helping us to create the array. Okay, another important thing we need to understand, and which will be an underlying thing when you are working with other libraries, is reshaping of the array. Okay, how do you reshape an array? So for reshaping an array, what you can do is, you can let's say a8 is equal to, let's create an array, np dot array array, and here I'll be putting let's say values I have put over here. So here I should write np. So here you can see, now you should be able to reshape it. Reshape means it is one dimensional, so you should be able to reshape it to 2 dimensions. So 14 are there, so I can make it 2 by 7 ka array, right? So let me just do it. So a9 is equal to, now we have a8 dot resjp reshape, and here I can make it 2 by 7. So print a9, and here you can see. Okay, so from 1D I have converted, I have transformed it into 2D. You can see that it is transformed into 2D. This is how you can work on the arrays for reshaping them. Okay, so in fact you can do 3D also. You just need to see that the number of elements are a multiple of the shape, like 2 by 7. That means 2 into 7 is 14. Total 14 elements were there. Okay, so similar way, you just need to ensure that there should be proper number of elements present in order to this do this thing. Okay, changing the shape. So changing the shape is required many a times when we are processing the data. So there we can surely make use of it. Make use of changing the shape. Okay. Then we have to iterate. Many times we have to iterate the values, and we know that from the fundamentals of Python we have for loop which help us for iterating purpose. So here also we can make use of for loop. Okay, so I can make use of for loop here as well. Okay, so here I'll do that for an, the last one is a9, let me take a8. A8. So for A in A8, now what to do? I'll be, you can see that. So sometimes we have operations, we want to iterate for those operations to be performed successfully. We need to iterate, and this gives us option of iterating. Okay, so this is how you can do. Use the for loop for basically iterating all the elements. So I think this much is enough, and we can jump over to the another library. Okay, so basic familiarity to NumPy arrays is required actually. So now you know that arrays are there. Some operations can be performed on arrays. Okay, so directly, many times we don't do perform array of operations when we are working with ML or deep learning. So, but many times we need to do. Okay, some basic operations we always have to do, slicing and all. We always have to do. So, that much understanding you are getting from this much. Okay, part. Let me name it as NumPy library. So after this, what everybody can do is, like, we can create a number of files in Google Collaboratory, or very similar way, we can create a number of files in Jupyter Notebook as well. So either of the tools can be used. And if somebody is already good with the Python softwares like PyCharm or maybe Spider, you can use that as well. There is no problem. Like, these are just IDEs where we need to type the code and execute. So if you are good with any other also, it is fine. Okay, so under file, I'll create new notebook once again. So I'll go to file section, I'll create new notebook. And now I'll help you how you can handle different files in case of when we need to work on data. So how you will be able to handle different files. And this handling will be done with the help of pandas. Okay, so pandas is another library. So let me, okay. Now once again, if pandas is not installed, okay, so you can install pandas. So normally it will be installed, but pip install install pandas pandas. This is how you can install it. And then second thing is to import pandas. So import import pnds pandas spd, and then we can make use of it. Okay, so it says that requirement already satisfied. And here what I will do is, so everybody can pay attention now. Here, this is the files section. You have to click here. After clicking this file section, this is upload option. Click here on upload, and then basically that particular sample EU dataset. So here I have that sample EU dataset. Okay, so you can click on that and open it. It will get uploaded over here. You can see it is getting uploaded. So similar way you can upload your data in this particular environment. So once the data is uploaded, these are the three dots you have to click, and three dots, and then copy path. This much you can do, copy path. Okay, so once you have done copy path, then you have to write data is equal to pd dot rad read underscore exel excel in bracket single quote and paste the path. Execute it and just check it whether it is loaded or not. So once you upload from here, then like you don't need to give any path. You can just give the name of the file in the notebook, like the way I have given here. So I copied the path, so content something like this it came. You can just give the name of the file, that's it, and it should load the data this way. Okay, is everybody done? So everyone can try loading this, and I'll just tell very few commands so that those who are still loading, so others can just try with data.had head. Inside it, you can write the number of lines you want to see from top. Again, data.til tail. Again, the number of lines you want to see from the bottom. So data.head, data.tail, and data.info, then next data.describe, describe. Okay, so just try these. Those who are done, just try these and give me a minute. So here we have import pandas as PD. Data is equal to pd.read excel. So whatever different file formats are there, we can read with the help of pandas. This one is pd.read excel. With the help of excel we are reading over here. And then if you just type data, it shows you the whole table, and this table we call it as a data frame. So here you can see that this table is known as a data frame. So yeah, this is data frame. It says that it has got 10,000 rows and 20 columns. So a data frame of 10,000 rows and 20 columns. And then with the help of data.head, you can see the limited number of rows. Let's say I want 10 rows, so I can just type data.head 10. It will show me 10 from the beginning. Okay, 10 rows. Similar way, I want from the end, from the last, so I can just type tail and then execute. So it is going to show me from the last. So here you can see, so from the end it is showing me. Data.info will give me the meta information of the all the columns. You can see this is meta information of the all the columns. What is row ID, what is order ID. So this is meta information. Data.describe will give me descriptives of the data, and this is going to give me descriptives of the numerical data. You can see that row ID, sales, quantity, discount, profit, all these are basically which columns? All these are numerical columns in the data. And apart from this, all of the columns are categorical columns. So it is not giving me anything about categorical columns. It is giving me everything about numerical, because if I want to get mean, that can be computed on numerical data only. Standard deviation, minimum. So all of these can be computed on numerical data. Then we have quartiles. You can see like from minimum to 25 first quarter, 25 to 50 second quarter, 50 to 75 third, and 75 to max fourth quarter. So we have four quartiles over here. So it is showing me that as well, quartiles. Okay, very basic commands of pandas we have explored. The most important thing I wanted to show you that because we need to deal with data, so we should be able to handle data. So pd.read excel we did. So one file was there with which we did excel. Now here also indexing, slicing, that mechanism. So we should be able to get specific columns. So let's say I just want the columns which are numerical columns: sales, quantity, discount, profit. So let's say I want those columns. So here what I'll do is I will just type data.columns columns. So this is going to give me the list of columns, and yeah, out of this list I will take I'll copy sales, quantity, discount, and profit. I'm copying this and I'm writing it this way. You can see data of, and here in bracket I'm writing it this way. So you can see that I have got specific set of columns. So you can also get the specific set of columns. So this is how you will get the specific set of columns from a particular data set where so many columns are there. Okay, so specific set of columns I have got. And after that, let's let's try to understand that whether there is any kind of you know whether there is any kind of relationship between sales and profit, or basically quantity and profit. Is there any kind of relationship between them? Let us try to understand that part. Okay, so I will tell you graphical way for that. As I said, we need to go through certain primitive libraries. These are some basic libraries which are required further. Understanding of these are required actually. So I will just take sales column and I'll just take profit column and I'll store them into a variable. So how will I do that? I'll take data and sales. So I'll take it like this. Let's say um, sales is equal to data of, I'll just take sales over here. Okay. So where is sales? This one is sales. And then similar way, I'll take the last one was profit, I believe. Yeah, profit. So PROFIT, profit is equal to data of, and here I'll put profit. So profit is profit. This is profit. So sales and profit I have taken separately in separate variables. Okay. Now what I will do is I will be using one library, that is matplotlib. So you can write it down along with me. From matplotlib, from matplotlib import pyplot as plt. So I'm doing from matplotlib import pyplot as plt, pyplot as plt. So this is the library. So here I just need to put t. I missed to put that. So matplotlib. Okay. So from matplotlib import pyplot as plt. So I have imported that particular library, and now plt dot I can plot sales and sorry, plt dot plot sales over here and profit over here. So sales and profit I will put here, and you can see that when I put sales and profit, okay, so this is plot. I think the better representation would be scatter plot. So plt dot scatter we can put, and it will give me in dotted way. So now you can see that what sort of relation is there between them. Okay, like not very strong relation. So I'm not able to see very strong relation here, because the strong relation should have been something like, for example, I'm just demonstrating here some dummy data. Okay, dummy dummy data. So strong relation could have been like x. If I have x as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if x is like this, and strong relation, you can see plt dot plot plot, and here x comma 2 into x. Okay, so here you can see that in this particular case, dot scatter scatter. So here in this case, what happened must be same size. So x just again. So here I'll take y is equal to, so if I do 2 into scalar x, so what is y? So this basically doubles up, so not this way. I'll just change it. So here I will take let me take values as 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And yes, let me remove this. So now if you see the kind of values now I have, okay, and in this I'll remove this, I'll put y. So this graph, if you see that this is highly correlated. Okay, as soon as x is increasing, okay, similar way y is also increasing. Increase in x leads to increase in y. This is what is happening here. Okay, in this particular case. So similar way, if you see here, this is about x and y. Okay, the next is, if you see that if I have x like, again something 23, 45, 12, 7, 89. So x is like this. Okay, so we have 1, 2, 3, 4, 5, 6 values in x, and then we have y, and y is 4, 4, 4, 4, 4. Okay, so 1, 2, 3, 1, 2, 3. Yeah, so this is how y is there. Fine. And now plt dot plot plot and or scatter, let me say scatter, scatter, and here I'll put x and y. So in this case, if you see the kind of relation, that whatever happens to x, y doesn't change. So whenever y is not changing, what is happening? This scenario, if you see, is that y has nothing to do with x, and there is no relationship between x and y. Okay, so technically we call it as correlation. So whenever we are basically looking into the variables, so here we are looking into sales, quantity, discount, profit. So we can plot the graph and try to understand that what sort of relationship they are having. This relationship is correlationship, like dependency on each other. So here it is very much less, because if you see that most of the data is gathered here, and it is very lightly increasing in this manner. Okay, like increase in x also leading to increase in y, but increase in x is also leading to decrease in y. You can see this data point, these data points, so it is decreasing also. So because of these data points, okay, these many data points, the relation is not very strong. Okay, so this we need to understand graphically before we are actually a simple way of feature engineering and selecting the features, that how to select the features in a very simple terms. If you are not able to see any kind of correlation, then better not to select those features, correct? So this is one way of handling the data I have shown you, and then how basically you can visualize that data with the help of Matplotlib, because we all know about EDA, exploratory data analysis. So before we actually go for performing some machine learning model or deep learning model, it is always good to just explore the data, and then you start with that. Okay, so that you have better understanding of it, and uh, yeah, and like when you are actually making the model, you know that the reason why you are selecting a particular column, okay, and its potential, that what that particular column can do. Okay, so this is one file I have explained you. Now let me take another file, and this file would be a CSV file. Okay, another way of making a connection, I'll show you. So another way of making a connection is with the help of a CSV file. Okay, so I'm just demonstrating so that you can get an exposure that different types of file can be there, and you can work with them. Okay, it's easy to work with them. I'll upload it here. The process is always same. You have to upload your file. Now you can see the file is getting uploaded. Let me just add few extra lines over here. Okay, this is REGULAR regular SEAS7 season data. In this particular case, data is equal to td dot read underscore CSV. We'll have to use CSV. Okay, so let it get loaded, and with the help of read underscore CSV, we'll be able to work on. Yeah, so it is about to load. You can see. So once it is loaded, then yeah, it's loaded. So let me copy path and let me put it over here in data. So this is another way that a CSV file can be loaded. Okay. So this function will depend on what type of file are you loading. Okay. Sometimes we have to bring data from database also, so you can use some connector to the database. You can make use of that. Okay. So this is how we just load the data. My intention was that you should be able to load the data. Secondly, you should be able to perform some operations. So we tried performing operations. Let me help you with more. So here, if you see that in this particular case, we have season. So I want like how many times a team, like teams are playing in a particular season. So therefore, what I'll do is I'll do it this way: data and of here, what is the column? Season dot value underscore COUN value counts. Okay, we should be able to get that for which season how many matches are played. Okay, you can see that season wise how many matches are played. So this we get with the help of value counts. Okay, similar way, here we have W score, that is winning team score. So if I want to know what is the average score, I can make use of, okay, again, data dot mean. Okay, similar way, data of, so again W score. Right, so you can use any aggregate function. Mean is there, sum you want to find out, you find sum. Okay, total, this is the total sum, minimum, maximum, all that you can find. So aggregations you can perform So as I was telling that before you actually proceed ahead with the any model, first you should go ahead and work on this way. Okay, like with pandas, you handle the data, and then you go ahead and you apply the model and pass your data into the model. Okay, with pandas, you can organize your data into X and Y also. That also you can do, right? So yes, there are more ways also. Like in SQL, if your data is there, you need to connect with that. In Google Spreadsheet is there, you need to connect with that. If it is coming from something like big data systems, you need to connect with them. So all that is possible. Okay, fine. So any questions till this point? Are we good till this point under these basics? Now, in fact, we can this is pandas. Even I used matplotlib here. matplotlib matplotlib also I used. So now let me create one more and then we will close. Um, like if we want to handle image also images. So even images you can handle with the help of these libraries. That is also possible. So I have taken one image, okay, and I have saved it also. It's in some different format, but let me check. So normally standard formats are JPEG or PNG. They are the standard format. Meanwhile, it is connecting. Yeah, connected. Let me load that image. Hopefully, I should be able to read it. Desktop. Or otherwise, do I have images over here? Pictures. Photo director 8.0. Do we have something? Okay. So even image files we can read as I said. So here I'll have to do install maybe one more library. So pip pip install pillow pillow. Okay, it's already installed. That's nice. Let me just copy the path. So copy the path, close it, and here. Numpy as np and import pillow pillow. That its name is pil. Yeah, they've got imported. Great. Now, now let me try. Okay, img is equal to image image dot open. I'll try to get the image here, and this is the path of the image that is loaded. And now let me print for you. So print img. This is img print mg. Hmm, hmm. Yeah, so it is here while printing RGB. So it's RGB image you can see, and the size is 1587 by 2245. So this image is stored in this particular manner. Now this can be used as an array. Okay, so we like it's there are 1587 by 2245 I can say pixels are there. So what I would try to do is I will convert this into array. So from NumPy I'll import as array array as array, and now img arr is equal to, here we will use as array as array, and I'll insert img inside it. Now you can print. So are you able to see this array? This is that image. This is in the form of array now. Okay, so even image data can be represented in the form of numbers, arrays. So therefore, this basic understanding was important, that whatever data we will have, whether it is in the form of a table or any kind of data, it has to be converted into a numerical data this way. Okay, so I hope this much is clear. Let me just add this numpy numpy img image array. Here we have, you can simply write plt dot, and mm, do it this way. This piece of code is there. I'm taking this separately here. So when you are wishing to get it into a file, then at that point of time, initially only you can write plt dot save save figure and give a file name. So I'm giving a file name as scatter scatter.png. So this is one file, or you want in PDF also, you can do that. So plt dot again save file save fig, and you can give scatter scatter.pdf. So these two formats I will get the data. Now plt.scatter is done. Okay, fine. So let me execute this, and this is executed. And let's go here. And here you can see that we have two files created. One is scatter.png, this one, okay, which has got, yeah. So once the design is over, after that this piece of code can be used. So this one is in PNG and this one is in PDF format. Okay, so only this much piece of line, plt dot save fig. Okay then. So yeah, any queries?